this video, we will be explaining how to solve compositions with inverse trig functions. Okay, so one of the types of compositions of inverse trig functions is when the inner function and the outer function are the same trig. It's just the outer one is an inverse. So for compositions like these, you look at the principal interval of the outer function, so the inverse of cosine. And the inverse of cosine is between 0 and pi. And pi over 3 falls in that principal interval. So you know that for questions like these, the answer is just pi over 3 or whatever is inside. So another example would be sine inverse of I don't know, pi over 4. And the principal interval of inverse sine is from 0 to pi over 2 and from 0 to negative pi over 2. And pi over 4 falls within the principal interval, so you know the answer is going to be pi over 4.
Does the inverse sine of sine 2 pi over 3 equal 2 pi over 3? No, because it's inverse sine, so you have to take into account the principal interval, which is quadrants 1 and 4. So sine 2 pi over 3 is located here, which is outside of this interval. So you find the value of sine right here, which is root 3 over 2. So you think about at what other place over here is the y value root 3 over 2. And the answer is right here, which is pi over 3, which is your final answer.
The inverse tangent of cosine pi over 6 equals something. Okay, so cosine pi over 6, you draw the little circle. Pi over 6 is right there. The cosine is square root of 3 over 2. So you substitute that into the cosine pi over 6, and you get tan inverse of square root of 3 over 2. Now, square root of 3 over 2 is not a special value. It's not on the unit circle, so you're going to need to use a graphing calculator. And the first thing you need to do is make sure that the mode is in radians for all test questions. And then you press second tangent so that you get the inverse tangent of square root of 3 over 2. And the answer you're always going to round to the first 2 digits. So the answer is going to be 0.71.
Be the arc secant, the secant of negative pi over 3. Saying arc is just like saying the inverse. So we have the inverse secant of negative pi over 3. And on the circle, negative pi over 3 is going to be down here. And since the principal interval is secant is the same as cosine, which is going to be in these 2 quadrants, we're going to have to flip the angle over the x-axis, so it's going to be right here. So the answer is pi over 3. Another problem similar to the one before is the inverse cosine of sine of 30 degrees, and 30 degrees is the same as pi over 6. The sine of pi over 6 is 1/2, so the inverse cosine of 1/2 would be pi over 3, which is, since they gave it to you in degrees, your answer has to be in degrees, and the pi over 3 is the same as 60 degrees.
Another example is sine inverse cosine negative pi over 4. And so again, you start with the middle. So cosine of negative pi over 4 is right there. That's square root of 2 over 2. So the sine inverse of square root of 2 over 2, drawing a circle, is either here or here, but you have to stay in the principal interval, which is quadrants 1 and 4. So it's going to be this answer, which is, again, square root of 2 over 2. Pi over 4. So the answer is pi over 4. For this problem, you need to figure out where 315 degrees is. So on the circle, it's right there, otherwise known as 5 pi over 4. The tangent of 5 pi over 4 is -1. So you get inverse sine of -1. And we know that is equal to 3 pi over 2. And since they give it to us in degrees, you have to give it back in degrees. And since the principal interval of inverse sine is from 0 to pi over 2 and 0 to negative pi over 2, this does not work as an answer. So you go the negative direction, and it's actually negative pi over 2, and in degrees that would be negative 90 degrees.
Another example would be the inverse of cotangent with sine inside the brackets, sine 3 pi over 2. So sine 3 pi over 2 would be exactly here on the unit circle, and the value of this angle is -1. So it would be cotangent, the inverse cotangent of -1. Cotangent is, okay, the principal interval of the cotangent is in the first and the second quadrants. This would be 1, and so this would be -1. And so this angle is 3 pi over 4. And therefore, the answer is 3 pi over 4. Queen meeting.
Avital, you are so dumb. This is a video.
No way! Sine of cosine of -3 pi over 4. So first we solve this area, so that would be -3 pi over 4. When you go backwards and when you go this way, this is where -3 pi over 4 would be. And so the value of this angle is, it's a -1 over root 2. And so the inverse sine of -1 over root 2. Since the principal interval for a sine is over here and all the negative numbers are going to be in the fourth quadrant, the inverse sine of a -1 over root 2 would be this angle right here, which is -pi over 4. Okay. What is 4.18 times the inverse cotangent of cosecant of 1/2? You can change from cosecant to sine by taking the inverse of this value, so that would be sine 2 times 4.18 cotangent inverse. Okay, but if you think about it, on your graph, the highest point is 1 and the lowest point is -1, so this doesn't exist. So the answer is DNE or NA, whatever you prefer.
Okay.
Be like, we made this unit circle into a cookie and then I'll karate chop it.
Okay, so now the unit circle holds no fear for you, because it's like a big cookie. You broke the cookie.
Crack the cookie!
Now the unit circle holds no fear for you, because it's just like a big cookie. Ow! She cracked the cookie. So that's how you solve various compositions with inverse trig functions. A general rule to keep in mind is always check that the values are within the principal interval, and you should be good.